Hello, everybody, and welcome again to my home. I am Patrick Rowley from the James E. Richmond Science Center, and I am here again with the latest installment in our SOSx, or Science on the Sphere Explorer series. So SOSx, in case you aren't familiar, is just an app from NOAA that you can get on your mobile device, phone, tablet, either one. It's a way to simulate our big Science on the Sphere that we have at the Science Center, but I do not have in my apartment. So what we're going to do today is look at some information about water or oceans. We spent some time last week looking at air, satellites the week before that. This week it's all about oceans. So I've got 3 data sets for you. The first one is all about buoys and float locations. So let's go ahead and pull that screen up bigger for you. All right, well, here we go. So we're going to, like I said, start out with buoy and float locations. Again, I'm having a nice time exploring some data sets I don't usually look at the Science Center. So this is one I haven't looked at in a while. And so what these are showing us are buoys and floats that are kind of scattered throughout the world's oceans, all right? They collect data about the oceans so that we can get a better understanding of what the oceans are doing and how the oceans change over time as well. So each little dot on the globe here is some kind of data collection buoy or float, all right? And you'll see that there's all these different colors of buoys throughout the world as well. So we're going to start off with some of the red ones, all right? And you'll notice most of those are kind of in the Pacific Ocean, all right? And those are DART buoys, D-A-R-T, or Deep Ocean Assessment and Reporting Tsunami buoys as part of the DART project. So they basically improve the capability of early detection of tsunamis out in the deep part of the open ocean out there. So they're able to kind of find those kind of small detections of a larger wave below the surface. And so we can get an idea of if there's a tsunami headed towards the land. All right, now we'll look at these purple ones that you see here on your screen. These are part of the TAO or Triton project, which is TAO stands for Tropical Atmospheric Ocean. And these are used almost dedicated entirely to the use of looking for and detecting El Niños and La Niñas. And that generally happens in this part of the Pacific Ocean here. There's South America, North America there. And so these are in this general kind of central area of the Eastern Pacific primarily. It goes across, and you'll see they're kind of in parallel lines as they go across the ocean to help detect the temperature changes that would indicate either an El Nino or La Nina season, because that is something that's happening in the ocean that has a global impact, but happens in that tropical part of the Pacific Ocean. Next, we'll look at Argo buoys, and you'll see a whole bunch of those. Those are in green. And these Argo buoys are part of kind of an open deep ocean project where they collect data from over 6,500 feet down below the surface and all the way up to the surface. These are pretty cool buoys. I remember learning about these a long time ago. And so they actually go down, and so they collect data, and as they rise up to the surface, they collect more data, salinity, temperature, all types of information and chemistry about the ocean. They get up to the surface, they collect all this data, and then at the surface, they're able to report that data out to through satellites, all right? And then they start going back down again and collecting the data. They come back up over and over again. You'll see these are all over the globe in our oceans. Again, those are the Argo buoys. Now, the blue and yellow ones are all are maintained by NOAA. And if we look at the blue ones especially, you'll notice that they're primarily, though not all, along US coastlines, but they are all near coastlines for the most part. And these are part of a CMAN, as in Coastal Marine Automated Network, CMAN. And they are located very near coastlines, even on piers, lighthouses, other near shore sorts of locations, and they're able to collect things like wind speed, direction, wave height, pressure, the ocean or the sea surface temperature there, the air temperature there as well, floating just off our near coastlines. Same thing with the other yellow NOAA buoys. They are all, for the most part, near coastlines, also maintained by NOAA, collecting similar sorts of data. And those are not just in oceans. You'll see there's some in the Great Lakes up here as well. So again, these are your buoy and float locations. All right, we're going to switch it up now to a favorite data set that we use in some of our field trips. That is here, our loggerhead sea turtle track. So we're going to kind of float that around to the Pacific Ocean, and we see these tagged loggerhead turtles, along with ocean temperature. So we're kind of combining two different sorts of data here. We have our ocean temperature along with the location of these GPS-tracked loggerhead turtles. And the way we use this at the Science Center is primarily in our 5th grade field trips. We're looking at how different Earth systems are connected. So here we're looking primarily at the biosphere, which is life on Earth. That would be the turtles in this case. And we're looking at the hydrosphere, all the water on the Earth. That would be the ocean temperature here. And so what we see is through time, these turtles are kind of moving with the water temperature, all right? So they're not staying up where it's very cold or down where it's very warm. They're kind of like Goldilocks, where they like things just right. And what they're doing is they're following their food sources, right? And their food sources are basically in tandem with the temperature of the ocean. So we're having different levels of interaction between kind of different parts of the biosphere as well as the hydrosphere, looking at how migration patterns are impacted by ocean temperature and food source locations. All right, and the last data set we'll be looking at today, I picked just because it looks really cool. This is ocean surface vorticity. All right, there we go. How cool is that? Yeah, so this is ocean surface vorticity, simulated vorticity by POP, which is the Parallel Ocean Program. Now, vorticity seems like kind of a fancy word. And so vorticity is basically kind of a fluid's rotation. It can be the air being the atmosphere. In this case, we're looking at the ocean water and how it is rotating through time. So it gives us an idea of kind of ocean currents in a way, but in a really cool, mesmerizing way to look at it, right? We have the different colors, which indicate your, not just the speed, but the kind of direction of movement. The greens are rotating in the kind of same direction as Earth, whereas orange is in the opposite direction. But the darker they are, the more, the stronger the current is. So here we're looking at the Gulf Stream, all right? And one of the more studied ocean currents in the world. It carries that warm water up the east coast of the US from the Gulf of Mexico. And you can really see how strong that current is going through there compared to the water on either side. Some other places that have very strong currents, if we look down here just south of Africa, we have some very strong currents there that send off these whirlpool type big swirling eddies. And it can take years for some of these eddies to make it across the full Atlantic Ocean. So there you have it. That's a look at the water on the SOSx app. There's a lot I didn't get to cover today, so I might want to do another water session sometime soon. Next week, I believe we're looking at land. So join us again next week for your next SOSx from Patrick's home session. All right. Again, stay safe, wear a mask if you need to go out, and wash your hands. All right. Have a good one.